Hi there, let's look at Pythagoras theorem. In this case, what we need is a right angle triangle and marked theta angle, and that is in front is opposite, by the side is adjacent, adjacent is adjacent, and then the longest one is the hypotenuse. Now, so any um, problem with right angle triangles, we can deal with use the Pythagoras theorem, that is simply c squared is equal to a squared plus b squared. That's the length of each side. And the simplest math example to understand is 5 squared is equal to 3 squared plus 4 squared, which is 25 equals to 25, right? But that's, you're not going to deal with that much. But what you will be dealing with is you're given ABC, but you're missing one. So that is C. In this case, let's say C is the unknown, and C can be calculated using root of the C squared is root of the A squared plus B squared. Why? The root and the c squared going to cancel out, so you get c here. So the c is actually root of the a squared plus b squared, right? So this situation can be applied. Let's say you're looking for b, then you still can use the c squared is equal to a squared plus b squared, and add the minus a squared to each side, cancel a squared to a squared, and swap the b squared to the front. So you get c squared minus a squared, and take the root of both sides. So you get the b. So that kind of the slow down and see what it is. That's the idea you want to know. Now, any problem based on this theorem in physics or math, so you want to be thinking for those 2 minutes that I was talking about the Pythagoras theorem application. So you're given two, you're missing one, right? So always that's the scenario. So now, there's another way. You want to see it sort of pictorially. The illustration is sometimes, speaks thousands of words. And let's see how does it how do we, understand this? And I would say three, the side of the three is 3 to the square. That means 9 little squares of yellow. And then the side of the 5, the hypotenuse, the longest arm, is, let's say, 5 blue squares, right? And that means 5 squared is, there's 5 times 5, which is 25, the blue squares, right? You can do the same thing for the adjacent, which is 4. Then 4 squared would be 4 cages with 4 times 4, which is 16, right? So that's the idea. So if you can see it that way, now we can actually see, like I showed, 5 squared is equal to 3 squared plus 4 squared. We can see in this picture that 25 squares, which is 5 squared, and we can see that is equal to the sum of the rest of the other 2 squares. So that means the blue squares 25 is equal to the 16 of the green and the 9 of the yellow, right? We also, if you remember that we were talking about the tiles for the factoring, right? That's a similar idea. So this is a good way to think, and rather than thinking about the numbers, you think about the squares and whether they matching the left to the right, right? That means simply 3 squared plus 4 squared is equal to the 5 squared. And that becomes 25 equals to 25, like we discussed at the beginning, right? So let's look at a good practical question that you might see in different types of exams, math, physics, and so on. So the idea, even in MCAT, so the idea is, let's say this is, I just thought about something. So this is, let's say we have a vacation house, and we are trying to install, your family goes there, you're trying to install solar panel, right? We try to go green every opportunity we get, right? So let's say I know x and y for this right angle triangle. We know x and y, but we need to calculate the hypotenuse, which is actually one side length of the solar panel. We are thinking for the one side of the roof, right? And that is z. So if I want to calculate z, I need to get x squared plus y squared is z squared. That's Pythagoras theorem that we discussed, and let's see how we're going to do it. Let's say I have the numbers for x and y, which is 5 and 12. Let's say 5 squared and 12 squared. I specifically chose this one because that gives you the good numbers, so you can't have decimals there, right? Now root of 5 squared plus 12 squared is root of z squared, which is z, and these numbers will come to 25 plus 144. Let's get the root of it. So yes, 25 plus 144 inside the bracket, and then we need to add them together first because brackets first, right? And then we're going to take the root of that number, right? So that'll come to 13 when you plug into the calculator, right? See whether you can get that. And if I know Z13, that's actually this side of the solar panel. 13, let's say 13 feet. Yes, I think it's a better idea if we go not imperial numbers, we'll go, sorry, with imperial actually, 12, 40, let's say 40 feet this side. And now we are trying to calculate how many solar panels actually we need, units, right? So, okay, let's try this way. Okay, now it's basically a rectangle, and I have 40 feet and 13 feet. And yes, the length is 40 feet and the height is 13 feet. So that means 13 times 40 will give you the value here, 520 square feet, right? Let's make it much simpler. That's how we buy from Home Depot, right? So now I need to count how many little panels that I need for the roof one side. So that is means if it is 1 square feet, so that will be 520 square solar panels we need, right? Let's say your dad is telling we need for both sides, then you double it, right? So kind of think how you apply and day-to-day life, and that's how your professors and teachers prepare questions, right? These guys use the theory and apply that into one of the day-to-day routine problem question, right? Okay, let's do another one. Let's say we are at the near the sky needle, the space needle at in Seattle, and let's say I'm standing by 350 meters away from the bottom of the um, space needle, and then I want to know how tall it is, but without reading the information, but I want to do the math, right? So let's say this angle is tan 30, 30 and 30 degrees, and tan 30 is how tall it is divided by the adjacent 350. So stop the video and give it a try whether you can calculate. So that's a good example to try. Now, another one, let's say we are sitting in an apartment building, and we want to know, no, we are sitting on the street side actually. So let's say we are away from um, 200 meters from the building, and then we wanted to know how tall this building is, and then we're going to use the similar idea here. Okay, another example would be, let's say I'm living in a much smaller apartment here. I'm at the rooftop. I'm looking at the taller tower in front of me. So here the angle of elevation is theta. So this is how you want to know horizontal to elevation. Now horizontal to downward, if I'm looking at the bottom of the street of this building, and that would be angle of depression. You see how you define angle of elevation and angle of depression. So then you can use tan theta to find out the x divided by 80 meters, which is the distance between the two buildings, and tan theta, tan theta is y over 80 meters, and tan psi, the depression angle, is actually x over 80.